this is our last example from 10.5. We have a tree farmer. He would like to know how much variance there is in the heights of the 2-year-old trees on his farm. Apparently he plants lots of trees. So these are the 2-year-old trees. Botanists generally say that after 2 years of growth, the heights of this variety of tree should have a variance of about 16 feet is the variance. The farmer claims that his variance is not 16. Now, he's not stating whether it's more or less than 16. He's just saying that it's not. So he selects a simple random sample of 40 of these trees and finds out that their heights have a standard deviation of 3.2 feet. So we want to know if this evidence supports his claim. We're going to do the point 10 level of significance, and we're assuming that the heights are normally distributed. Okay, so step 1 is to get a pen. Okay, we want our null and alternative hypothesis. Let's see, we're talking about variances again. Okay, so that's sigma squared. The farmer says it is not 16. That's what he wants to show. So the null hypothesis is that it is 16. That's what the botanist said it should be. Step 2, since this is variance, we have to use a chi-squared test. And we are told that alpha is going to be 0.05. All right, step 3. We are going to calculate our test statistic. So this is n minus 1 s squared over sigma squared. Okay, how many trees was it that he had? He had 40 trees that he randomly sampled. So 40 minus 1. And then his standard deviation was 3.2. So we have 3.2 squared. Over, and we need sigma squared. In our null hypothesis, sigma is already squared, so you just write 16. You don't have to square that again. So let's see. When we put this all into the calculator, 24.96 is what I got. Okay, so now we need to compare this to something. We need to do our rejection regions. So we have a two-tailed test. Okay, since it's not equal, this is a two-tailed test, and our degrees of freedom is 39. All right, so in order to do a two-tailed test, we need to look for two critical values. We need 1 minus alpha over 2 and also alpha over 2. Okay, we're going to have to find both of those. And the reason it's alpha over 2 is because it's split into two parts. Okay, so we are looking for 1 minus alpha over 2 is going to be 0.95, and then just alpha over 2 is just 0.05. Okay, so when we look this up on the table, we should get, let's see, for 0.95, I get 26.509, and I also get 55.758, it looks like. So let me put this on a graph so we can kind of see what's going on. This is a two-tailed test, so we get to reject if we're on either end of this. Our two critical values are 26.509 and 55.758. And we need to see where our chi-squared, our test statistic, falls. Okay, so 24.96 falls in this rejection region. Okay, clearly in the rejection region. So our conclusion is we are going to reject the null hypothesis. We were in the rejection region, so we get to reject. So interpreting this, we're going to say at the 0.10 level of significance, the data supports let's see, how do I say that? The variance of heights of the farmers, so hard to write it all, 2-year-old trees is not 16 feet. The botanist said it was supposed to be, but his is not. Now, since he ran a two-tailed test, he can't make any determination about if it's more or less than that. It appears it might be less than that, but if he wanted to prove that at a certain level of significance, he would have to run another test for it. So these are the steps for hypothesis testing for population variance or standard deviation. Works basically the same way. Again, your graphing calculator is not going to do this, so they're all by hand. But hopefully you see it's not a terrible process. So you can work on your homework for tonight, and we will be back together tomorrow.